wiring issues, elephant's foot, first layer Z offsets, auto bed leveling probes, all this and more. PrintFix Friday, episode 70. Let's get into it. Hey guys, welcome back to the channel and welcome back to YouTube's longest print fail fix video series that happens weekly. We appreciate you guys coming by, learning a little bit about the fails. Remember, if you want to submit your fails, have me take a look at them, you can do so by hitting us up on all the social media, sliding into those DMs, or utilizing our direct email, which is youtube@3dmusketeers.com. Links, of course, in that description down below. Greatly appreciate your help in making these episodes a little bit easier. See, the more fan submissions we have, the more help we give to real people rather than just grabbing random ones off the internet where they might not actually ever see the responses. Got a lot of great fails for you today, so strap in and let's get right into fixing those fails. All right, first up, we've got a fail from one of our Patreon members, Logan Luckless, who having a bit of an odd extrusion issue. Works fine there. You can see the gear turning, but when you push it all the way back, the gear doesn't turn anymore. And that is a wiring issue. Any of you that have big printers like this or bed slingers will eventually run into this wiring issue. Over time, copper, aluminum, and basically any material that we make wires out of will work harden and fail. This sucks, and there's no easy way around it. The best thing that you can do here is keep an eye on it. Now, we can narrow this down a little bit into what part of the printer it is. It's likely the stepper motor that runs the extruder. But if you don't have a spare stepper motor cable or the means to make a new cable, you are dead in the water until you can get spare parts. It's why I talk heavily about having spare parts on hand all the time. It is a big deal to have it, and I think you should have it as well. There will be an upcoming channel video where we talk all about spare parts, what you should have, and why. Because ultimately, if you don't have the spare parts, you're stuck until you can get those parts in. If you're smart enough and you can solder wires, you can go ahead and cut them and resolder them, but you don't know where that break is. It could be right at the connector, or it could be somewhere along that big loop of wire. It is actually the most common failure mode that we see on the Prusa Mark III's behind me, is that their bed thermistors will fail because the wires have broken. And it's why I keep gobs of them in stock, so I can easily just replace it and move on. It is easier to do that than it is to try to track down where the break is and solder it and all that. I can't be bothered. Replace the darn cable. It's just a better move. That's what I recommend here as well. But it is a fun problem that your printer, unless it has Hall effect sensors on the motors, will not detect. It's just not going to print in one area and then randomly start printing again, and it will drive you batty until you realize it's a wiring issue. This doesn't seem like elephant's foot. What could be the problem? Well, let's take a look here. That is Z-wobble. I can tell you that is Z-wobble. We've definitely got some wiggling here. It looks like we got Shaq and we got a cat that really wants to get at something doing the little wiggle over here, and I'm not a fan of that, so we definitely need to look at your Z-axis, but that is 100% elephant's foot. And why is it elephant's foot? Because your Z offset is not correct. If you have issues like this where your first couple of layers look really, really weirdly squished, check your first layer because it likely looks like this. Now, you might say, Grant, that looks like glass. Yeah, it's from the bottom side. I care about the top side. Your top side likely has lots of little peaks on it. That will be a massive problem for layers 2, 3, 4, and 5, as it is slowly trying to go through your errors and make them right. Is there a good solution here? Yeah, just redo your Z offset. If it is something that a Z offset is not fixing, then let's look at a warped build plate. If it is a warped build plate, a piece of glass is going to be your best bet. And then if you want to put a PEI flex plate, you can put it on top of the glass. Unfortunately, this means really, really long times for the bed to come to temperature, and don't believe what your bed thermistor says, because it's not going to be right, at least according to what your real bed is going to be, and you will lose some Z height. Not too much, but a little bit. But is it better than having a warped bed? I think so. But yeah, be careful on this one. It looks like your Z offset is too close. Go back to Wednesday's video, take a look at it, and you'll see there's easy ways to solve this. I have faith in you. We'll card that video so you guys can take a look at it as well, and link to it down below too. What could be causing visible line on the right side of my print when there is no line on the left side? I can see lines on the left side, but fine. And then on the right side, we've got some pretty serious lines. Now, I don't know how old you all might be, but this is ramming. This is what happens when you pull it out and put it in way too fast. I initially thought this might have been caused by a partially clogged nozzle, but this right here is very obviously a Z-seam of sorts. And you can see that it is failing on the initial extrusion. And when you're running an ender at 130 millimeters a second, which you should not be doing, 70C is way too hot for PLA. 210, fine. Hatchbox, fine filament, no issues there. But that is absolutely ramming. When it comes to Bowden printers, you have to deal with the filament coming in and out of the hot end quite a bit more than you do with your direct drive machines, because direct drive only needs to pull it out a little bit. You don't have too many issues with backlash in direct drive where you do with Bowden. And that big movement means the filament will cool down as it is out of the hot zone, or at least quite a bit out of the hot zone, away from the nozzle. And that means when you insert the filament again back toward that nozzle, you must slowly allow it to come to temperature. 55 to 65, maybe even 75 millimeters a second retraction is fine, but your de-retraction, you don't want to go any faster than about 35, and even that is pushing it. I would go down as low as 20 or 25 millimeters per second, and that should solve a lot of these issues. But I'm also noticing some under extrusion here. This is a bridge, and with how much infill we have, this shouldn't be a problem. But even further, the infill lines are not connecting either. Now, I don't know if this is grid or if this is rectilinear, where grid, you have crisscrossing patterns that occur on the same layer, and rectilinear where it is on top of each other like this, layer after layer, where it's lines that are alternating every layer. If it is rectilinear, then your settings aren't right. If it is grid, your settings absolutely aren't right. I do recommend that for infill, you up your extrusion width for a 0.4 nozzle up to at least 0.45, if not 0.55, give you a little bit more strength on the infill. I would check to make sure that you are extruding properly, but looking at it, you might be. I just think maybe your extrusion width might not be 100%. We can see though that they do have some issues with this speed. On this corner, which I believe should be sharp, we've got a bit of a bulge coming out of it, and I'm not one to judge another person's bulge, okay? We're not that type of channel. We're certainly not going to talk too much about ramming speeds, but this is absolutely indicative of a machine with too much backlash. So take a look at your Bowden to make sure it's not overly worn. If it is, replace that bad girl with some cap tube, and you can thank me later. We'll reduce some of the backlash that you deal with in a Bowden system. This is an ender, but I don't know what ender it is. Based on the textured surface and the binder clip, I'm going to assume it's a Gen 1 Ender 3, but I'm not 100% sure. For the love of all that is holy, what am I doing wrong? This is a printer that has a bad Z offset, but this build plate has seen some things. We are looking at a build plate on an Ender 3 V2 that is running a CR Touch. And when you do run a CR Touch, you want to make sure that you remove your Z offset, because now your CR Touch is your Z offset. And a CR Touch, for those that don't know, is Creality's rip-off version of the Ant Collabs BL Touch that they stole from Ant Collabs, because that's what Creality does. They steal other companies' IP, and I will continue to bring that to light until Creality stops becoming a popular printer brand. They shouldn't be, because they don't care about you, and you shouldn't care about them. They might make a cheap printer. There are other companies that make affordable printers. In fact, I looked at one, the Sobel SV06. Actually, I looked at a pair of them on a live stream that happened a week ago, where I unboxed them, assembled them, and did a benchy live on the stream. That was a fun stream. And if that's your kind of thing, click the link in the description and up in the card. You'll be able to take a watch. It's a pretty long one, but it was a lot of fun. This printer has a lot of problems. And when I see problems like this, I can't help but bring in why people utilize 3D Musketeers. We are experts for a reason. And while we might still have print failures, in fact, this person behind me has a print failure, and I stopped it in the previous recording of this that got killed because of a computer problem. Hooray. But we are experts for a reason. While we still might have print failures, and for some it's more common than others, we don't make that your problem. These parts will still be done in the morning for the client, and that's really all that they care about. That's what we do here at 3D Musketeers. That's a sub 24-hour turnaround time. While not normal, they are absolutely going to pay for it. That's the way this works around here. And if you want to outsource your 3D printing, whether it is for big jobs, small jobs, one-offs, or even miniature production, we can help you here at 3D Musketeers with over 40 years of experience and over 40 3D printers helping you make awesome every single day. We also have 3D scanners should you want to take a physical object and make it digital for printing. We also have an entire team of engineers to help you with those ideas that are in your head that you want to make physical. This is what we do. We make awesome. That's why we always tell people to make awesome, because that's what we do here as well. And if you do want to support us and you don't want to outsource any 3D printing or 3D scanner or anything like that, you can support us with a YouTube channel membership or Patreon. Links are in that description down below. And at the $10 tier or higher, you get to come hang out with all the awesome people in our Patreon Discord server who are responsible for providing most of these failures that you see here today. Thank you guys for your support. But don't forget, if you do want to submit your fails, you can do so. We have a way to do that. And of course, email is one of the better ways. All of that is down below. But in this particular case, this build plate and likely the nozzle are shot. We can see what appears to be the nozzle dragging around the bed. For those that don't know, carborundum, which is what Creality calls their build surface, is silicon carbide. That's what carborundum is otherwise known as, silicon carbide. Silicon carbide goes more commonly as sandpaper, and sandpaper against brass means you're going to have a worn nozzle. In a case like this, I might recommend getting a new glass plate as well as a flex plate. A flex plate will make life a lot easier. And I know I said this was going to end, but it hasn't. Our Wham Bam code, which is Musketeers 2022. Yes, still 2022. Will get you 10% off over at Wham Bam. And I got a little care package from them. We got some slat mats in, along with some other fun stuff that we're going to be using in an organization video, because I know I need it, and that likely means some of you need it as well, where we build an ideal workbench. I talked about it in a previous video. It's coming soon, so make sure you get subscribed if that is something that you want to see. And don't forget, Musketeers 2022 for 10% off over at Wham Bam. It's exciting. Save you some money. So they are having this issue where overall things aren't sticking, the lines aren't working right, and eventually the prints do fail, which, from what I can tell, that's what it appears is going on here. I believe that, one, you've got a bad nozzle, and two, you do need to go back and look at manually leveling this thing. We need to verify if this is a software issue, a hardware issue, or something in between. When doing the unboxing of the Sovels and the first print, it was made very clear to me by people in the comments on the live chat that, Grant, you need to click store settings after you do your Z offset and after you do your initial mesh bed leveling. It is required for the printer, because otherwise it's not going to store the settings that you just did. Maybe that's a case here too. I don't know. But I believe that starting to upgrade a machine like an Ender 3v2 is not always the best move. Eventually it will become a Ship of Theseus problem where you have replaced so many components that is it really the same printer again? And while I understand it is quite a bit of fun, going to a machine like a Solo SV06 and Elegoo Neptune 3 Pro Plus or Max will likely give you a better printing experience than what you are experiencing here. Now, that doesn't mean to just yeet your printer out the window, but what I do think we should do is go ahead and disable that auto bed leveling probe for now. Go ahead and manually level the print bed. If you don't know how to do that, we talked about it in a previous video. We'll card to it so you can take a look. And if that still doesn't work, let's see if your bed is actually tram and the Z offset is set correctly. Because if it's not, well, none of that's going to matter anyways. Looking at this surface, though, you're also going to want to replace that build plate because, yeah, it's seen some shit. This person is saying, turn the bed around and calibrate it with a Post-it. And they're saying to flip it over to the clean part of the glass plate. That is a great move to make, and I highly recommend that they do that as well. But if your nozzle has been grinding against this carborundum plate like I believe it has, it's time to replace that thing as well. MK8 nozzles are relatively cheap, so you don't have to worry about it too much. Go get it replaced when you can. I don't know, man. It looks like it's way too close on the edge and way too far in the middle. This thing might just be really badly warped. I don't know what to tell you other than you gotta start somewhere. And I would start by removing the BL touch or the CR touch and utilizing something that's a little bit easier, like doing it manually for now. And if you do choose to do so, the Filament Friday leveler is a relatively affordable option that will basically guarantee a perfect first layer. I mean, you saw me do it and it worked great for me. I think it'll work great for you guys too. Links in the description. I recently got some new things for my printer, 0.4mm steel nozzle, a magnetic bed, and ever since I've had bad prints. This includes no bed adhesion, bad layer adhesion, and whatever affront to the gods you see in the picture here. Does anyone have an idea on what's going on or how to fix it? Thanks. So we've got a blob of doom that was reasonably well protected by a silicone sock. We can actually see clean heater block in some of these photos, which means the silicone sock did its trick. But what we have here is someone that does not know how to replace a nozzle. One of the things to note, replacing a nozzle is not as easy as just unscrewing the old one and screwing a new one in. You can't do that. You will have to remove the current nozzle when it is hot, and the metal has expanded and allowed you to take it off. It is my preference that you then also put on the brand new nozzle at that same temperature. With a printer like this without an all metal hot end, it is best to do it at about 230, 240 degrees centigrade. Any hotter than that, you start risking breaking down that PTFE liner. If you do want to take out the liner, you can go hotter, but your firmware will likely limit you to 260 degrees centigrade. With an all metal hot end, I recommend up to 290 C to go ahead and remove that nozzle and replace it with a new one. And make sure that you hot tighten everything. A cold tighten will not get everything good, and you'll have a bit of a gap between your nozzle and your heat break. You are wanting to put the nozzle and the heat break together, and they want to be as close to one physical piece of metal as possible to keep the filament from coming out and coming over. And we can see that is exactly what has occurred here. It looks like a lot of this issue is stemming from the top of the heat block and where the heat break and heat block come together. And the film is just coming over, getting underneath the silicone sock, and well, just causing a bit of a goo disaster. Thankfully, this is a relatively easy thing to fix. Get the printer heated back up, remove the filament from it, let it sit there and bake for a little bit. A lot of that filament should just melt its way off. And you can use something like a pair of ceramic tweezers or X-Acto knife or something. If you're really careful, if it's metal, be careful because you don't want to short your hot end out, to clean off any of the excess material. As you do that, just be aware it might not ever be the same again. That carbonized plastic that is now stuck on the inside of your heat break is going to eventually boil its way out. So be careful. You will still have some oozing as you go on. But the silicone sock, I think, did a lot of help here to save this day. So good on you. Make sure you have spares. As far as bed adhesion and bad first layers, when you do replace the nozzle, a lot of times it's not going to be exactly to the way that it was previously. And you will have to redo your Z offset. So make sure you do that when you do replace your nozzles. Now, on printers that have E3D Revos or other ones where the nozzle bottoms out and functionally cannot move and there's no way to really torque it, it's just hand tight, you're pretty much good to go. You can just outright replace it and not have to worry about any Z offset. But for printers like this, it's always better to go ahead and redo that Z offset. As far as bad layer adhesion, if it is a hardened steel nozzle, not a stainless steel, and even if it is a stainless steel, you will want to up your temps by at least 5 degrees, but normally between 10 and 15, sometimes as high as 20 degrees centigrade, higher than normal. Do a temp tower to find out what works best for you. Steel has less thermal conductivity than brass, and that means you need more heat. It's why I love the diamond nozzles. They are more thermally conductive and mean you need to lower your temperatures versus hardened steel where you need to raise your temperatures, which lowers what type of materials you can use on machines like this that don't have all metal hot ends. Although this one might, I'm not 100% sure. The ones that don't have all metal hot ends, if you put a hardened steel nozzle on them, you're pretty much lowering your ability to use materials. And ABS, you're on the upper echelon of being able to print ABS. Not that I recommend that you do, but you'd be on the upper echelon of it. Case like this, clean off your hot end, make sure to tighten your nozzle when it's hot, make sure everything is tight, and you'll be good to go. If your nozzle has bottomed out on the heat block, then you likely didn't order the right nozzle, or it's not long enough for your use cases. You know, if I had a nickel for every time I heard that, I might be a rich man. In a case like that, make sure you tighten your heat block more, but not too close, right? I look at this and say, there's a pretty decent gap here. You might be able to get another turn or two out of your heat block before needing to look at a different nozzle. If your nozzle doesn't directly fit, just look at getting a different nozzle. That's my opinion. What could be the problem? We've got, well, partial clog. That's what we got here. And Z-wobble. We got a lot of Z-wobble. Let's go back and look. This photo is pretty much the only one we need to see. We have some issues with inconsistent extrusion. It kind of fixes itself. It kind of fixes itself again. Then it really doesn't fix itself. And you know, the recovery ain't bad. I will give it credit. But we do definitely have some Z wobble here, or some sort of banding from your axes. Something that I noticed on Cheaty printers, or Keedy, it's the QIDI brand. They have springs on their belts. If your printer has springs on the belts, take those off because it will give you ringing. Now, this is not ringing, this is Z wobble. And what this likely is due to is the Z axis. V wheels are not tight. We've talked about this previously, but I'm going to do an updated video on it with better B-roll this time about how to tighten your V wheels. But basically, you want to tighten them so they don't just freely slide. You want them to force that rolling motion. That will keep them from moving too much when they're not supposed to be moving. But we definitely have a mechanical issue here, and we've got a filament issue. Now, the filament issue has sorted itself out. The filament is running just fine again, so no harm, no foul. But if you do notice, and if you notice it down here, you would have been able to kill the print, clean the hot end and move on, but you did at one point have a partial clog. I would bet somewhere amongst all this bad printing, you'll find some just black garbage that was clogging up your nozzle. A good thing you can do is do a cold pull or an atomic pull. They're basically the same thing. You heat up your hot end to operating temperature, you extrude some filament. You then cool it down to about 90 to 100 C. You can even go as low as 70 if you want, but it really does depend on your material. I think 100 C is a pretty good mark. You then remove all extruder pressure, you push in and then out really fast. You pull it out really, really fast, and that should give you what appears to be an impression of the inside of your hot end. You want to keep doing that until the filament comes out clean. It is a great use case for all that crappy white filament that comes with your printers that you should never print with because it's garbage and it's white filament. It's terrible to begin with. The only white that I like is design white from Printed Solid. I'm sorry. I'm a little biased. They let me tour their facility, but I was still a fanboy well before that. And if you do want to see what it does take to make filament, it was a lot of fun touring Printed Solid. We'll card to that video so you guys can take a look at it as well. But here, this is mechanical and of course a filament related thing. Go ahead and do that cold pull and atomic pull just to be safe. And I think that's a better move for you overall. And then fix those V wheels because I think you got a little bit of wiggle going on. Why are there random gaps in my print? These gaps would appear right after a popping sound, even though I was using PLA at 200 by 60. This is potentially wet filament. That is the sound that you will hear. You will hear a popping and hissing and a cracking. This could also just be really crappy filament that is just creating a problem. I don't know which one it is because the rest of it actually looks pretty clean. Like, that's not a bad looking print and not indicative of something that is wet. I'm not seeing any stringing at all. Now, mind you, I can't see where we might see stringing, but I don't see any at all. If there is some sort of stringing, that would tell me that it's wet filament, but this might also just be from cavitation in the filament itself. So we can see that people are saying popping sounds are clear signs of moisture. It is water literally boiling and exploding as vapor as it hits the extremely hot nozzle. This is true. That is what the sound comes from. This explosion of vapor blows the surrounding filament away, creating holes or pockets where this happens. Just need to dehydrate your filament, remove the moisture. It helps to invest in a dehydrator. Absolutely yes. Someone is asking if there is a DIY way to dehydrate filament. There is. Go get a food dehydrator from your local thrift store. You can get them for relatively cheap. Cut out the grates in it and just stick filament in it. It works great. And if you're feeling extra special, you can drill a hole in the actual exterior case of it and install Bowden tube connectors so you can run a reverse Bowden setup. You can also get filament dryers, and I do want to do a rundown of filament dryers. So hi, companies out there that make filament dryers. If you want me to review yours, send me an email. Let's talk, because I want to do a rundown of filament dryers and compare them to each other and see what I like and what I don't like about the filament dryers out there. It might be wet, and if it is new filament, that doesn't mean that it's dry, especially when you're buying cheap filament. This is Hatchbox, so it's been sitting at Amazon. If for some reason that seal was broken or it's been sitting at Amazon for a long time, chances are that filament's absorbed moisture. You'll see the clear bags that are used, those don't really block a lot of moisture. It is the Mylar bags that tend to block a lot more moisture. You'll see Mylar bags more common on high-end materials like nylons and polycarbonates that tend to be very hygroscopic. And you'll see what we choose to do here is we use resealable sous vide bags on the last cart here. This is our exotics cart that has all of the things like TPU, carbon fibers, polycarbonates, and all of that. And while we're pointing at that, we should pet the kitty. Because why not? Victoria needs a little bit of love too. Wow, that's it? You wake up, you notice that I'm petting you, then you're like, screw this, I'm going back to bed. It's tough being her. Can I get a like for the cat? So we also have some conflicting information that the retraction is too high. I don't know. So they're saying that the retraction is already 3 millimeters. It could be cavitating for trying to pull too much filament. I've seen both happen. I'm gonna lead more toward wet, and it's easier to deal with wet filament than it is to try to play around with this it's filament cavitating problem. Oh, and it's a direct drive. Okay, yeah, if it's a direct drive setup, 3 millimeters is too much. You can go down to like 0.8. Sorry, it's not common that printers with Mark 8, it's a Mark 8, it's not a Mark 9, that have Mark 8 hot ends on them are direct drive. So if it is direct drive and you're running 3 millimeters of retraction, it's way too much. It might actually be cavitating at that point. Yeah, it doesn't look like wet filament. It's got the indications of wet filament, but it doesn't look like it. I'm not seeing lots of popping and hissing. I'm not seeing that they're complaining about smoke coming out of their hot end, which is really just steam most of the time. It could be that it is too much retraction. Do I know for sure? No. Both of those are very easy things to check. The retraction one is easiest because it's a quick little settings change. The other one of drying the filament takes a little bit longer to figure out. That is really all that I have for you guys today. Make sure to comment down below. Let me know what you thought of PrintFixFriday episode 70 now that we're back on the less memes, more help side of things. But stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. Hey, thanks so much for watching this video. A massive thank you goes out to all of our Patreon and YouTube channel member supporters. Thank you all for what you do in making this possible. Remember, if you want to help support the channel out, you can do so by clicking those links in that description down below and joining for as low as $1 a month. And if you do want to join the degeneracy that is our Discord, it's a $10 tier or higher. Right below me will be the entire PrintFixFriday series, which is full of good advice, memes, and sometimes I get it wrong. Go take a look. I think you'll enjoy it. Next to that will be our entire series on getting to know your 3D printer because, well, a lot of people are new and it's time that we put something together that's a little more educational for them as well. I'll see you guys down in those comments and in the next one. Take care.